Hello and welcome to another video on rationalising the denominator. In the previous video we looked at a technique of getting rid of this irrational number from our denominator, and how we did that was we multiplied the numerator and the denominator by this number here. So we multiplied the numerator by root 2 and the denominator by root 2 because we weren't changing the value. This is just 1, we weren't changing the value, but that allowed us to get rid of our irrational number in our denominator. Now what we're going to do in this video is going to be, we're going to move on a step, but this time instead of just having one term in our denominator, now we've got an expression with two terms in our denominator, one of which is an irrational number. So we're going to do the same thing, we're going to rationalise the denominator, so we're going to get rid of this irrational number. Now in order to do that, it's a slightly different technique than previously. Instead of multiplying the top and bottom by root 2, I'm going to multiply the top and bottom by this whole expression, but I'm going to change one thing, and that is this sign here. So I'm going to flip this negative to a positive. So I'll show you what I mean. So I'm going to multiply the numerator by 3 plus root 2. Notice how this expression is the same as this expression, but I've just changed the sign. And obviously I'm going to do the same to the denominator. And again, I'm not changing the value of my expression because I'm just multiplying by 1. Okay, but hopefully when I multiply this out, you'll see that this gets rid of this irrational number. So let's have a look at the numerator first. So 6 times this expression. So if we expand the brackets, 6 times 3 gives us 18. 6 times root 2, that gives us 6 root 2. Now here, the denominator, so we've got two expressions, so we're going to multiply out these brackets. So however you like to multiply them out, you can use the grid method or the FOIL method. I'm going to use the FOIL method, so 3 minus root 2 times 3 plus root 2. So if we focus on the first terms, 3 times 3 is 9, 3 times root 2 is plus 3 root 2. Negative root 2 times 3 is negative 3 root 2. And finally, the outside terms, negative root 2 times positive root 2 is negative 2. Now you might be thinking, after all that, after multiplying out all these brackets, I'm still left with irrational numbers. But you might be able to spot something, okay, in these middle two terms. So first of all, let's just concentrate on the outside numbers, so the whole numbers. So we've got 9 subtract 2, well that just gives us 7. Now this is the important part. We've got positive 3 root 2 and negative 3 root 2. Those will just cancel out. That is just 0. Anything subtract itself will just be 0. So all we're left with in our denominator is just 7. Okay, so we have rationalised the denominator. We've got rid of our irrational number. And I don't think we can simplify this anymore, so that is actually our final answer. Okay. Now don't worry if you didn't get that first time, because we're going to go through a few more examples. So let's have a look at this one. So again, we're going to rationalise the denominator. So I'm going to multiply the top by 1 minus root 5 and also the bottom by 1 minus root 5. So it's the same expression, I just changed the sign. Now if we have a look at the top, so 4 times this expression, 4 times 1 is 4. 4 times negative root 5 is negative 4 root 5. Now our denominator, again I'm going to use the FOIL technique, so 1 plus root 5 times 1 minus root 5. So if we concentrate on the first terms, 1 times 1 is 1. Now the outside terms, 1 times negative root 5 is negative root 5. Now the inside terms, root 5 times 1 is positive root 5. And hopefully you can see now that these will cancel out. And then negative root 5 times, positive root 5 times negative root 5 is just negative 5. So again, look at the whole numbers. 1 subtract 5, well that is negative 4. And then negative root 5 and positive root 5 will just cancel out. So all we're left with in the denominator this time is negative 4. So again, we have rationalised the denominator. Now you could leave it like this, but you might not get full marks because it isn't fully simplified. They might ask you to fully simplify your answer as well. So I can see that we can divide the top and bottom by negative 4. That will get rid of this fraction. So 4 divided by negative 4, well, that would be negative 1. And then this divided by negative 4, well, that would be plus root 5. And that is our final answer. Okay, if you're a bit unsure of how I went from this to this, then just need to get a bit more practice on simplifying and dividing by negative numbers. But these two expressions are equivalent, but this is just a fully simplified version. Okay, let's do another one. So let me scroll down. Okay, this one's slightly different because we've got two irrational numbers in our denominator, but we're going to use the same technique. So multiply the numerator by root 3 plus root 2, and multiply the denominator by root 3 plus root 2. Okay, so in the numerator, 8 times root 3 is 8 root 3, and then 8 times root 2, well, that's just 8 root 2. Nice and easy, that one. Now the denominator, again, I'm going to use the FOIL technique. So root 3 minus root 2 times root 3 plus root 2. So let's FOIL this out. Root 3 times root 3 is 3. Root 3 times root 2, that is plus root 6. Negative root 2 times root 3 is negative root 6. And again, these ones will cancel. And negative root 2 times positive root 2 is negative 2. So let's simplify. 3 subtract 2 is 1. And then plus root 6 minus root 6, that's 0. So in our denominator, we've just got 1. Now, if we've got a denominator of 1, I don't really need to write that. So I could just leave my answer as this. This is fully simplified. I don't think I can simplify that anymore. I could factor an 8 out, but that won't really be simplifying things. So this is our final answer. Okay, I think I'll do one more just because this is quite a lot of fun. So hopefully you're getting the gist of this. So next one, I'm going to multiply the top and bottom by root 10 minus root 8. Root 10 minus root 8. So in the numerator, root 2 times root 10. Well, that's root 20. And then root 2 times root 8, that is root 16. Okay, we will be able to simplify this later, but I'll just leave it like that for now. Okay, now let's expand, multiply the denominators together. So we've got root 10 plus that should be root 8. And then root 10 minus root 8. Okay, again, let's FOIL this out. So root 10 times root 10 is 10. Root 10 times negative root 8 is negative root 80. Root 8 times root 10 is positive root 80. And again, these will cancel. If for some reason these won't cancel, you must have gone wrong somewhere. And then finally, root 8 times negative root 8 is negative 8. Okay, so we've got 10 subtract 8 is 2. And then those two will cancel. So we've got 2 in the denominator. Okay, now let's simplify. So root 20, that's the same as 2 root 5. Because root 20 is the same as root 4 times root 5. And root 4 is 2, so that's 2 root 5. And then root 16 is just 4. All of that over 2. Now we can divide the top and bottom by 2. So we'll be left with root 5 minus 2. We could write over 1, but we don't need to write that 1 in our denominator. So that is our final answer. Okay, I'm going to leave it there for now, but hopefully that gave you a good understanding of rationalising the denominator when we've got more than one term in our denominator. So it's a slightly different technique to that we saw when we only had one term in our denominator. So thank you for watching, and I hope you enjoyed that.